All right, learners. So what we're going to do today is we're going to take a little bit of notes to go with the reading that we just completed, whether you listened along with me or you read the pages on your own. This will be some notes that we can add into our science notebook. So go ahead and title your page, How Do Scientists Collect Data? Because this is what our notes were all about today. It's right there. And we should probably first start by defining what data is. Okay. So what data is information from which a conclusion can be drawn. So data is information. I'm going to go ahead and move this and I'll move it back. It is information from which a conclusion can be drawn. So whether it's pictures, whether it's numbers, whether it's recordings of something, data is information from which a conclusion can be drawn. Okay, so that's our main goal with data. Now, we want to make sure that data is recorded consistently or the same way every single time. So we want to make sure data is collected the same way each time. If it's not collected the same way each time, it could bring about errors in our collection methods. It could bring us different results, which is definitely not what we're looking for. You want it to be consistent. Now, one of the things our reading talked about a lot was precise versus accurate. And so what I want to do for this part of the notes is actually just to draw 3 different targets. So I'm going to pause the video. I'm going to go ahead and draw my 3 targets. All right, so I've drawn 3 different sets of targets. So when you are target shooting with like a bow and arrow, your goal is, of course, to hit the center. Or whether you're playing darts or whatever game you're playing, your goal is to hit the middle. That's the outcome that you want, right? That's what's correct. So now what I want you to do is to label each one of these. Which one is precise, which one is accurate, and which one is both. Now remember, precise means all the answers are close to each other. Right, so all your data is really, really, really similar. Accurate means it's close to the right answer. And so what we're aiming for in science is to have both precise and accurate data. You want them close to each other, but you also want them close to the right answer. So we have this one is precise because they're close to each other, but they're not close to the actual right answer. This one is accurate because they're all kind of around the right answer, but they're not super close to each other. Now this target is both, right? Because they're all close to each other and they're all close to the right answer. So we have precise, we have accurate, and we have both. And that's really what we want in science. So we want precise and accurate data. Sorry, the A got a little messy. I set up, but keep bumping the camera. So precise, accurate, both. Now, if you have data that's precise, maybe it means your measurement tool is off. Maybe it means your scale is wrong, right? It's consistently wrong, but maybe it's wrong. Now, last week we talked a lot about tools in science. And so scientists use tools to help collect data. Right? You can feel that your forehead is hot, or you can take your temperature to see how hot is it, right? It helps you collect data more precisely. Okay. Now some tools that the reading talked about that we hadn't talked about yet. Microscope. Right? This allows us to see things that we couldn't normally see. A calculator. Another one we have not talked about yet. This one we typically think of in math class. But this actually helps us in science a lot too. I like to say often that math and science often shake hands, meaning that they are very similar sometimes. And so we use a lot of math in science, therefore sometimes we use calculators to help us out with our data. Then I went on to safety, right? So what I want you to do, and you can make a choice here, is you can either draw or you can write a couple different safety things that they highlighted, right? So I'm going to try and draw. This might be kind of rough, but we've got a scientist, and she's got kind of long hair, so she puts it in a ponytail, right? Because you want to pull back your hair. She's going to be wearing goggles. So I'm going to say hair pulled back. Hair pulled back. Say goggles. Let's say she's wearing, oh boy, just gave her weird hands. Let's say she's wearing gloves too, right? These are all different types of safety things that we can use as scientists to help us protect ourselves. Another thing is like closed-toed shoes, right? Making sure you listen to all directions, making sure you're wearing your proper equipment, that kind of thing. Now, the reading then goes on to talk about organizing data. And we do that in a couple different ways. We can do it in tables and graphs and charts. Well, let's just do tables and graphs. Those are kind of the two that we're going to use the most in 5th grade science. Is we're going to organize with tables and we're going to organize with graphs. The last note that we kind of want to highlight is all about inferences. So an inference is a conclusion based on an observation. Now, you've probably talked about inferring in reading, and that's kind of the same thing as an inference. So an inference is a conclusion, don't worry, I'll show you underneath the cam here in a second, based on observation. So you see something, you hear something, you smell something, right? And this inference then kind of leads you to the conclusion. So if my dog is whining, I can also see that the time is 5:30 p.m., which is when he normally eats dinner, and I can see that he's whining and he's standing near his food dish. These are all observations I can make. Therefore, I can infer that he's hungry, that he wants dinner, right? So this is a conclusion that I can make based on what I see, what I hear, right? So that is your notes for today. Thank you for following along. I'll take a picture of this and upload the completed one as well in case I went a little too fast. So there are your notes for today. Thank you. Bye.